Hello everyone, I'm Sandra Fix, Global Marketing Manager Industry at GFT. Welcome and thank you for joining our webinar on fast data in industry. If you're not familiar with GFT, we are an IT services and software engineering provider with more than 30 years of experience working in financial services, insurance and industry. With more than 6,000 employees, most of them software engineers, in 15 countries, we are driving digital transformation of the world's leading companies. Today, we have an exciting agenda for you. I hope you will enjoy listening to our speaker, Pedro Nieto, Senior Software Engineer and Fast Data Expert at GFT, who will show you how you can benefit from fast data technologies in industry. During this session, Pedro will guide us through the reference architecture and show us exciting business cases. We will be keeping time for questions at the end, so if you'd like to submit questions as we go, please type them into the chat and we will try to answer just as many as we can during the Q&A session. So then I would like now to welcome Pedro Nieto and hand over to him.
Thanks, Sandra. Hello, everyone. Thanks for joining. First of all, I would like to introduce myself. Sandra has done a very brief introduction. I will give a little bit of background, so everyone knows who's speaking to you today. As Sandra mentioned, my name is Pedro Nieto. I'm based in Valencia, in the southeast of Spain. I'm a data engineer or software engineer based on data, whatever you want to call it. In GFT, I have been working in GFT for the last 10 years in different areas. We can talk about all the areas mainly focused around data. We talk about big data, IoT, data management, artificial intelligence, different areas where I have been working for the last years in different projects with different clients. And also my hobbies. What do I like to do on my free time? I enjoy technology, and I'm a little freak about Raspberries, Arduino, and all these things that I like to prepare at home. Now, once this is done, and I have presented myself, let's talk about fast data. Okay, why do we talk about fast data? I mean, what is fast data? I'm not going to jump to any conclusion. I'm going to go step by step. I will start explaining what fast data is, how it appears in the picture, what it means to everyone, and why do we need to take into account in our day-to-day business or in our industries, okay? If we take a look back, and as I mentioned, I have been working in GFT for the last years, for more than 10, and if I talk about traditional systems, is when I started working in this, there were systems that were mainly focused on loading data. Every data to do what we normally talk them transactional, like you have an ETL where you get the data and you store it in a database, where you have different tables where you show the data to the client, to the user, and they can do whatever they want. That's what we normally talk about traditional systems. They can be very valuable. They fit for purpose. I'm not going to say that, okay, if you have this, you are 20 years back in time, you are old-fashioned. No, they still fit for purpose, but the problem is that every step we take in the way, new needs appear to the ecosystem. So the first step was, what happens if the volume of data that I want to process is too big? What happens if the kind of data that I want to process is not just structured? I mean, it's not client data, for example, is pictures, is image, is sound, is that sort of things that they don't fit into a normal traditional system, and they are too big to be processed in the normal way. You can always scale. Probably a lot of companies will come and say, if you get the best computer system in the computer PC in the market, you can process whatever you want. But this is not the approach that the market has followed during the last year, which is the big data ecosystem, where we were capable of growing, not just scaling vertically, we were capable of scaling horizontal. So we could create with a low budget, create as many servers as we want, and split the work and match the expectation. This was probably the first step. Some years back, we will see a timeline later, but sometimes back which made possible to process big volumes, huge volumes of data in a certain amount of time. But what happened? One is we have talked about the volume, we have talked about the structure, but what happened if we talk about the velocity of the data that we need? That's where comes the trick. We can still process data, and if I tell you that if I work for a bank account, for a first-tier bank, and you have the account, and when you check your account, the time spent to process all your movements was around 1 minute during the night, it won't be a big deal. But what happens if you need the data instantly, and data gets to your system on a event base, and the time is your main goal. Even you reach a point where data is no longer valid if it doesn't arrive on time. That's where fast data has arrived. During the last year, we have seen that we want everything instantly. I'm not going to start talking about why WhatsApp is the main way of communication versus the phone, and I'm going to sound like my father. But the idea is that we want everything instantly. Okay, we can't wait for data to be processed, so that's why fast data has gone into a picture. But what speed that's your business need? If we stop a moment, as I mentioned, if I have a traditional system, it's working for me, it fits for purpose. Does it mean that I'm going to get legacy? I'm going to stop working? Is my business continuity in risk? Should I raise a risk in this? No, the point is that you have to see where you want to go. And what is the goal for what is the next step you want to achieve? If you ask your stakeholders, and okay, who's the client for my data? If I ask them, they use and say, when do you want your business? When do you want your data? Or what's the business need? And they said, my data, I just look my data once a day. I don't care if the data takes all the night to get processed. I only takes one look every day, or takes a look for the full day batch process. It's fine. You can still wait. You can still. That's what we normally talk about. The speed is not my thing. A nightly batch. Okay, so you can still maintain your system using ETLs, traditional ETLs, just normal database. That what we call, for example, you will find the ecosystem, Informatica ecosystem, even when Informatica have solution for the rest, but the main goal, Power Center, these sort of things are for this batch-oriented mode, okay? But what if we get one step further? I got into the big data ecosystem. Now I have a big data ecosystem, but I need to process a lot of the data, but a little bit more faster. I mean, I need to process data, but I need to process it in the moment. I can't wait all the day to be processed. That's when Apache Spark appeared and was one of the frameworks created by Apache ecosystem to process data in the closest to real time that we have in that moment, which was capable of distributing the workload to maintain this time of response and provide a fairly response time with batch, which is a great solution for this kind of problems. But if we go one step further and we say, no, I need fast data. I need the data to be fast. I need data to arrive in microbatching. I need time of response below a minute. It means that if an event is generated by some place in my business, I need to get all my calculation done less than a minute, and I show it on a screen, so I can have the insights as soon as the data arrive. That was the main evolution from Spark to Spark streaming, and it got what we call microbatching, which means that you have a time window that's getting smaller, so you get to a point where you have around 1 minute window or something like that, where you feel confident about it, but that's that you have velocity, but you are not in a final stage of fast data. But what happened at the end is that that's the end of the road. No, the end of the road nowadays is what we want to present is the fast data. That's as fast as light. This is streaming data. That means that we are talking about systems providing insight in sub-second ecosystem. It means that since the event is generated from the moment it's shown, all the ecosystem, all the infrastructure is under second. So we are in a sub-second ecosystem. If we go to the market and look what do we find in there, one of them is Apache Flink. It's as I have followed the rest of Apache ecosystem, that's the equivalent for the Apache. Even you will find something like Beam if you go to Google or any other solution in that way. But you have, as a summary for this slide, what I want you to be clear is that there is no wrong answer to your ecosystem. It's just incorrect if it doesn't fit what you want to achieve. If you approach your business and you want sub-second insights, you can remain on Spark or on a batch mode, because you will face at the end of the road, you will face a bottleneck where you won't be in a position to overcome. And why do we know this? I mean, if we take a look back at GFT in 2002, for getting a point in time, we started working about, or we were already working on data sourcing and integration projects. If we look at the top, we'll see that probably Tableau, I hope it rings a bell to some of you. Cloudera was founded some years back. And in 2005, we have our first data integration program using Power Center. We were very close to the beginning, partnership with Informatica for a long time. And we keep on maintaining this relationship with the data ecosystem and bringing our clients the solution we think is fit for purpose for each of the use case based on what we find in the market. If we take a look, 2016, for example, we were in a position to start talking about artificial intelligence, or one look back on 2015, we were in a position to create our center of excellence about data based on our experience we have. And for the last 4 years now, that we are in 2021, for the last 4 years, we have been delivering fast data solutions to our clients based in the mindset that a fast data ecosystem needs to fit the purpose. Okay. But what a fast data approach? And some of you will probably ask, okay, this now you reached this point. Okay, I have heard this many times. There's a new technology that comes to the market, and now they are selling everywhere. That's what's going to solve everything. This is not mainly a technology problem. This is an approach problem. The idea is that no matter what you do, if you have an incorrect approach, no matter how long you squeeze your processes, but you will end up at bottleneck. That's why the fast data approach helps you to think in a fast data from the beginning. And that's where our experience can help you to start from the beginning. Okay, let's ingest the data. If there are two ways of ingest data in a very high level, you can talk about batching. You can ask every 5 minutes, and then you can go on an event base, where we'll talk event base. If you go to the ingest, if you go to the batch, you made a decision for the rest of your ecosystem. No matter what you do after all, you are already breaking the streaming picture. So ingest, process, and insights should be all designed and thought as a global picture for fast data. You can use whatever technology is behind it. You can choose your own technology that fits this purpose, but the overall architecture needs to be aligned with these concepts. Benefits of fast data. I'm not going to repeat myself and say that we are in a moment where the data is very important. If you are on these webinars, because you already know that data is one of the key things that we'll find. Probably they used to compare that with gold. The gold maybe now is the Bitcoin, but it's going to be one of the main important things for the next time. With the fast data, you can react to a problem when it's generated. And maybe if you read this sentence, react to a problem when it's generated, and I talk about whatever you want in your systems, your day-to-day activities, say, okay, when something happens in my system, I can react to it. So I'm doing fast data. Let me give you an example. Imagine that you are driving a Tesla. If you are a lucky one, you can drive a Tesla in the highway, and something crossed your road, and the Tesla has to make a decision about stopping or avoiding or whatever. Okay, activating the brakes. Keeping this in mind, will it make a difference 5 seconds between avoiding the obstacle or going through that already run over, that would probably make a difference. That's where we want to place our situation. Those are the scenarios where those 5 seconds really matter. If it doesn't matter for you 5 seconds more or less, you are not on the need of fast data. But if it does match your need, that's where you need to change this approach. Also, you always get updates with the insight. If I'm for sure, I can bet that if you go to your stakeholders and you say, when do you want to receive your data? When do you want to receive your reports? Do you want them live reports that every time something changes, you want them of live, or do you want to wait for an hour to get the data processed? I can bet that the answer will be probably the first one. That I want everything reflected. The sooner, the better, the faster, the whatever you want to call it. And that's what we face with our clients as well. Also, this leads us to one of the points, which is the risk reduction. The longer the data is, the longer the invalid data is processed in the system, the bigger this problem becomes. So if you imagine that you get you get an event, you get data that is incorrect or is false or it has bad quality, and you put it in your system and you spend 8 hours processing this data and generating insights going back. It means that you have spent 8 hours on a false based on a false data. You will have to rerun, you have to reprocess, you have to clean the data. But if you work on a fast data approach, you know that you get the data and in the next second, you get the next version. So you are on a safer way, okay? And also reduce this infrastructure cost. I'm not going to talk about cloud, but they go hand by hand. If we talk about fast data, and if I tell you, probably one of the questions you have in mind is, yes, you talk about sub-second, but what if I throw you 1 million messages per second? Can you feed the pace? Can you keep the pace with this volume? That's where cloud comes to the picture and give us the ability to grow in elasticity, to become bigger when it's needed, and reduce the volume when it's not needed. It's not mandatory to be in there, but it's a good practice to align these sort of resources together with the fast data. Okay. But where do we use this? I mean, now you're probably wondering, okay, I don't see any use case where this rings a bell or it doesn't ring a bell for my business. But there are some scenarios where this is quite mandatory. Let's put some examples on the ecosystem we normally work. This is the kind of clients we normally have, these sectors. So if we go for example, to banking, real-time risk management is the moment where you calculate what's the risk on an operation, or in know your customer, know your client process. Imagine that you are opening a bank account and you provide your data and they need to calculate what's your risk. If it takes hours, you will tell your client, okay, you need to wait hours to clear your account. Or if you can do it in seconds, you can say, okay, now we have already checked and this is already working. So now you can move your money, you can do whatever you need. Also for your investment, whatever thing you want to do in the banking is closely related to having a fast data ecosystem. Okay. Insurance. We worked in the past with these kind of scenarios where you can have the flexible. Nowadays, if you have a car, the most common thing is that you pay an insurance no matter what happens during the years and no matter how you drive. They will probably ask you about how old are you, how long have you been driving, what kind of car do you have, but no one is going to sit in your car together to you and say, okay, you're a good driver. For an hour, it's going to sit there, you're a good driver, I'm going to give you a good insurance. No, the idea that we have with the insurance is that they will become more tailored solutions where you can process the way you drive in a real time. And maybe what if you could get only charged by the time you drive? So you process every minute that you drive on your car, and based on how you have driven that car for that minute, you get charged. That would be a different model. That would probably something we will all be happy to use, so we don't pay when the car is in the garage. But what about the next? Manufacturing. Is that a place where we can use fast data? Of course it is, if you talk about anything you want to measure. the first step, if you wanna work with real data, is that you need to measure that data. The data you measure in real time, you can activate whatever machinery you need. You can switch off machinery if they are overrunning in time or in energy or in any step that they need. You can cut the power or do whatever action you need. And in the automotive, we will see some of them later, but it's a fact that the cars are becoming more a source of data than just a car. If we take, I think it's Tesla, the one that generates around 15 gigabytes of data, I think, a day for one single car. So probably it's a big amount of data that we need to process on more time, okay, in real time. Now is the moment when all the technical people in the room open their eyes. This is what we all expect when we go this kind of webinars. What are the tools that we can use? What are the pieces that we need for my puzzle? And yes, there are different pieces, but as I mentioned before, this is not only a technology problem. It's an approach problem. So it's a strategic problem. It's how do you want your business to behave? Do you want a business to react in real time, or do you want a business to delay hours, the decision, and the insights? That's the first decision you need to make. Then, next step is find which are the suitable tools that we find. If you go to the market, the things you will probably find is that if you need to monitor in real time, you have something like you have at the top, Grafana, Kibana, Elastic, these sort of things. If you go to the ingestion, probably you will need to choose between Nifi and the Basium as CDC. One of these pieces will make the deal. In the stream processing will be, as I mentioned, Kafka, Flink, Beam, these sort of things as the common suspects that we find in our ecosystem. If we go to a client and they show us a reference architecture and say, okay, I'm thinking about fast data, and we don't see these sort of things, that start suspecting that we are maybe on a micro batching, we're maybe on a batch mode, but we need to think how this improves. So these are the pieces we need to find there. If we go to the data access layer, you will probably see something like Flink again, or data service to the user to consume the insights, this sort of thing. And also in the platform, something about the scalability on Kubernetes or any other way of escalating in the cloud, on premise, wherever it is stored. Okay, so we have seen the technology. We have seen why fast data we think is important. Now I'm going to show you some quick samples to give you a little bit of food for the thought, and see if that's exactly what your business needs, and see how we can find a deal. So the idea is, let's first example. This was connected car telemetry platform. We had the luck to work with Google during proof of technology using last year. The idea was, once you buy your car and it's your own car, OEM, which are the car manufacturer, they don't get any data from your car. So imagine that you have a faulty brake and they don't get any sensoring from that data. The question was, what if we could get all the data from the cars in the market when they leave the facilities and keep on maintaining that data and processing that data in real time? We could send alerts to the clients about something is going to break, or we could do something fancier in the process. For this use case, the idea was that we were with one of the logistic company with fleet management that was working in moving packages from one to the other, that's logistics. So the idea was, in case we found out that one of the trucks was gonna fault in one piece of the car, we automatically were in a position to send another truck to the position, notify the driver and tell him, okay, stop the car where you are, another truck is gonna appear in your picture and it's gonna replace everything you have, and it's gonna send it to you, whatever action you wanna make, okay? Also the optimization. Reading something like the traffic, we were able to get the information about the traffic and recalculate logistics and optimize routes for the ongoing activities. So if you know in advance normally what happens in these kind of scenarios is that you are a driver, you get to your work, you get your truck, you fill your truck with all the package you need for the day, you start your route, and no matter what happens during the day, that no one is going to ask you again, no one is going to give you more feedback, or no one is going to change your route. Okay, that's what we want to change. That's the idea of changing from a batch mode to a real time, when the driver was completely updated and a real time about the data that he needs to satisfy his work. So if we get as a summary of this use case, what did you achieve? Real-time telemetry data. We were getting more than, I think it was around 200 parameters from an OBD. If you don't know what an OBD is, it's the data sensors, that the data port that you have in your car to get the data. And be in a position to, this is where the scalability and the cloud comes into the picture, be in a position to maintain the throughput of the data if we scale to more than 5 million cars in a minute. Imagine that you have 0 cars and the next minute you have 5 million cars sending data, and the platform is capable of processing all that data in the same speed, just escalating and de-escalating the ecosystem. And from a business perspective, provide a predictive maintenance model, which was able to respond to the question about how the car was behaving and give them the warnings about if something was happening. Back again, for those who come with that technology, some food for the thought. This is the architecture we use for that. You will probably see some IoT pictures, some Firebase, some connected, some pops-up messaging. All the pieces you see here, they fit the requirements of being elastic, being streaming, and providing data in real time. So all of them were in a position to provide data and do not become a bottleneck in the point of process. Next one, if we get one step more, now we jump. The first one was a fully cloud ecosystem. All the data coming in streaming, no more enriching sources. Then we face a second scenario. Here in this scenario, we went to company focus on machinery, monitoring machinery in different points of the world. But they were also enriching that data with their ERP, MES, any other system they have in their picture. So the idea was that if we take a deeper look into what they do, you can see how they handle different trucks, how they handle the pumps for the oil that they are pumping out, what's the situation of the pumping based on temperature, based on where they are, different measures. Okay. So what was the main goal? Provide them real-time analytics. Imagine that you are in a center, in a command center in your office, and you can see all the machinery that they have around the world, and see in real time how they are behaving, and activate or deactivate from there all the actions that you can control kilometers away. Okay. That was one of the main goals, to provide that, but not the only one. They wanted to track as well to track the trucks, or all the sending of all the oil they were sending out from one point to the other. They want to track these assets and provide predictive maintenance and machine status for the machines. They have, if you know this kind of industry, they were in a 24/7, 365 days a year. So they have what we call a planned stop. So you only have like 3 hours to do whatever you want. So given the chance of knowing in advance what they need to change, because in the next cycle it's going to fail, save a lot of money. Okay, that's one of the main goals of the predictive maintenance, and why fast data was good in here. But what's the difference? I mean, what was the good point? The good point is that you may be wondering that in the first scenario, you had an ecosystem where everything was cloud, everything was streaming. So it makes sense, if I do streaming, I do everything streaming. But what if I have a system that is not streaming per se? And you have an ERP or CRM, they do not stream. They just send data whenever you ask them, or they have a batch mode. Is that a limitation? No, the idea was that you can work on streaming all the data you can handle on streaming, but you can enrich that streaming data with all the static or non-streaming data that you can process as well. So you can do a mixture between batch and real time and get insights in real time about that data that is arriving on real time. For example, imagine that I get on real time what is the cost. I mean, I'm getting the status of a pumping oil machine. If I get a sensor that said this sensor is a 90% predictive failure, I can go to my ERP and check, okay, how much does this piece cost if I go to the market and buy it? So they say, okay, you have a 90% and the cost of this failure is 500 euros. Okay, so you can make that kind of maths, which is streaming, but based on ERP data. This in this situation, it was a cloud base as well, but we were mixing, as mentioned, batch data with streaming data. So again, technology people, and how this architecture looked like. So we have two pieces, two doors for our data. One is NIFI for the streaming data, and the other one was Informatica for non-streaming, for the batch ingestion from SAP, Oracle, or any other API that we were getting our data, but also getting the messages or the events from a streaming like Google. One curious thing that you will probably come to your head is, okay, you have Azure, you have Google. As I mentioned, and I want to repeat this because this gets like a good statement, is fast data is not a matter of technology, cloud, or proprietary solution. It's a matter of an approach for your business. So if for matching that you have different cloud provided, it's not a problem, it's not a limitation. You just need to keep thinking in a streaming process using the pieces you have in your business. Not going to change anything, okay? It's not a limitation because you have different cloud providers. Okay, so let's get a little bit more. Next one is, okay, so we have seen the scenario where we have streaming, native streaming, so we get the data, everything is streaming, everything works. We have the second scenario where we have batch and we have streaming. Now we are going to the scenario where we have batch data, which became by need and streaming data. This was a collaboration with a company to build a smart city solution. The idea was that they were receiving batch data about weather, rush hours, public transport. All the platform was designed to be batch mode, micro batching mode. So they had one architecture was, okay, we process data, we have like 5 minutes delay. We process in Hadoop with a Hadoop system. But they reached a point where some of the events were arriving in streaming, and the architecture was not capable of dealing with this in real time, getting to bottlenecks when the data was arriving in real time. The problem was on their side. So what we achieved here, and we worked together, was how do we migrate the approach? How do we change from a micro batching ecosystem to a streaming ecosystem? And if it was just technology, I could just copy and paste code. But the point was, you change from Hadoop to a Kubernetes ecosystem. You change from something growing to a fully scalable ecosystem like Kubernetes, and you allow the platform to be elastical and to capture IoT sensor in real time. So you can translate to your stakeholders, to your clients, all the data as fast as possible in your real time. And also stop providing insight every 5 minutes, change to be a real-time dashboard. Okay, that was one of the changes. If you want to take a look, it's probably a little bit more complex to explain, but you will find some like the pods for Kubernetes. If you have worked with them, you will probably know what they are. Some balancers, some different pieces that you will need, some REST API, this sort of things that will be probably the pieces that you need in a streaming application, migrating from a micro batching, for example, or a batching approach. Next one is, okay, we have seen more or less all of them. Okay, we have seen what happens with batch, with streaming pure, migration between batch and streaming, whatever. The next piece is, what if I don't want to go cloud? What if I want to put my own streaming, but I don't want to use a cloud provider? This is the scenario that we have with one of the TV providers in Spain. The idea was that imagine that you are watching your TV and you made a decision about something you don't want to see, something like I offered you a football match and you reject watching a football match. The next suggestion that I'm going to make you, it can't be another football match, because probably that's going to give a bad user experience. When I said I don't want to see sports, I don't want to see football. So those kind of response are the kind of things that we have to do in batch data. Imagine that they give you, I don't want to see football, but for the next 5 minutes, everything you offer me is going to be football. So it's not going to match the expectation of the user that is handling. And the user in this kind of things is quite stressed. I'm going to give you more an example about something that happens to me, which is an example of fast data. If you have ever tried to watch on your mobile TV a film, and you are watching your film on your mobile phone, and you reach home, you stop your phone, you put the TV on, and you resume the film in the same exact moment where you were watching on the mobile phone. That's a streaming solution. That's a fast data solution, because you can do that on a very low latency solution. Okay, which are the benefits for here? What we achieved with this TV provider was capture the streaming video user events provided by the hardware and calculate what's the KPI for the quality. I mean, imagine that you have a situation where you offer 1,000 people football match, and 90% of them reject that football match. So the point will be that, do you need to keep on offering the football match to the rest of the people, or will you change your bet to any other content which has not been rejected by that? Okay, that's the kind of KPIs that we were calculating. If we go to the volumes, this is huge. This is really huge volume of data, generating around 4 terabytes of data per day, more than 400K events per second. If you think about 400 events per second, you will probably need to plan accordingly an architecture, and you will probably need to plan accordingly an infrastructure. This is the difference between the rest. The rest of the examples were supported by the cloud ecosystem. Here was more an on-premise solution built by the client, but it was completely capable of being done. Just the fact that it was not used by any cloud provider. How is the infrastructure? This is how it looks like. We keep on always talking about Grafana, Elastic, Kibana, all real-time based solution, always Kafka and Flink in this case, and Kubernetes. As you see, the technology ecosystem that we find normally repeats, but if you come here and you don't want to have Flink, you can find any other solution in the market, or if you want to change the other, we'll probably have an alternative. But these are the main leaders and the most common thing that you will find in this kind of architecture. Okay, now I have just recapping. I have explained how a pure streaming, batch on streaming, migration on premise, on cloud. Those are a lot of things, a lot of different situations where you can use your fast data architecture, or at least the fast data approach. And why do we see this from GFT as an opportunity? Because when we see this, because we see this as a natural evolution of the system, it's not rocket science. If we go back to the first slide, I tell you why this is going faster and faster. Is because the market is requesting data to be faster every time. So from GFT, what we know from our experience is that we are in a position to consult and to support all the streaming architecture needed for your current problem or your current situation, coming from industry IoT platform, industry planning and control, predictive maintenance, all these things that are probably used in the market as common words, but we try to make them real in a fast data with a low latency response time. That's what we achieve based on our experience in the streaming architecture. If we go one step more, what is the next step that we can provide to our client? is the fact that you have the real-time decision. As I mentioned before, you can find that your client, your stakeholders, they find real-time decision as something that they do or they already do. They can make a 5 minutes response. They can do whatever in 5 minutes, 30 minutes. But when you reach a bottleneck that you need under second solution, this is where we know that we can help you to give these kind of solutions for mobility, transparency, everything to get to a point where you can provide the tools for the decision. Maybe the last but not least is the data as a service. There are a lot of situations with our clients where they find a secondary market that can be sold as a service or can be used to increase new lines of business where having the data in real time can lead up to new market opportunities. If this appears in the picture, it's going to be a game changer with the rest of the rest of the contendant in the industry sector. If you have those data in a better position to shape the market if in case of need. When we talk about this, we talk about production and logistics, we talk about machine data. Just keep in mind an example. Imagine that you are a logistic company, and in the market there are 5 logistic companies. One of them is streaming real-time data where the packages, where the trucks are, where all the pieces are in real time, and the other ones work on a daily basis. Probably, if they are not very bad and using the data, they will get a position where they are in a power position to gain the market and increase the market sale. Okay, same for the massing data, and the same for any improvement you want to do around your productivity, production line or assembly line or anything you need in your massing data ecosystem. And how do we do it? How do we make this possible? And it's not, I would like to have magic. I mean, I would like to do this is magic and you trust me and I do magic and that's all. But obviously it's not going to happen that way. So we have tested a framework, and we put in place a framework with our client that lead us to a situation where both parts are trust each other and are confident with their situation, with the position, with the steps we make. What this means? If we go to the first step, we go to the ideation process. This means that we find our spot where the client and us, we work together in a co-creation mode, where we find what is the situation where you really need fast data. This is what I think. This is what I have to change all my architecture to this, and we try to assess if that is a real scenario, if that's going to be fixed based on our experience, or there are other steps to need to be made before. Conceptualization, once we agree about what we want to achieve, we get a point where we translate that into the best solution in the market we can find about technology. As we didn't mention this, but we are technology agnostic. So every time a client comes to us, if they don't provide any requisite, we go to the market and we find the best solution that fits our clients. It's not selling something because it's the thing you have to do. It's just find the best solution for our clients. When we have done this conceptualization, we reach a point where now we're confident about this. Let's build our first POC, our MVP, where we see the ROI in weeks time, where we see the data flowing, where we see the insights in real time, and we make this tangible, we make this real to the client, and we reach a point where the client can say, yes, this is exactly what I needed, or no, this is not what I needed. We need to go back to ideation, we need to step back, or we need to redesign, or really, it's not the case I wanted. We reach a point where it's not a success. We have to face those situations, but that's the way to test it. Once everything goes successful, we go one step further and we go to implementation. We have software engineers globally. I think it's 12 countries around the world where we can help you to implement these solutions. Our engineer team can support you in the different phases in the different aspects of this ecosystem, giving you the chance to forget about all the needs you have in the technology and just focus on what will you do with the data in real time. And once we get to the point, let's run the services. We have evolved. It's not just magic, but we need to help you evolve. Even if we make something working, the rest of your organization will need to evolve accordingly and start getting momentum, start getting speed about this fast data, so everything gets into the same speed. Okay, that's the point where we reach about run services, and that will be the moment where probably we'll be in a situation where all your companies start moving in the same pace using the fast data. Reach this point, and I hope you all. This is the final state of my presentation. I hope you all enjoy the presentation. Now, I don't know if there are questions, but if there are, I will just try to answer them as good as possible. So, Sandra, do we have any question?
Hi, Pedro. Thanks for your presentation first. Very, very exciting insights. Thanks a lot. Yes, during the webinar, we had some interesting questions coming in via chat. So the first one is somebody says, hi, do you see fast data as a new technology or is it anything else?
I think that's a good point. I mentioned before, but the fast data is a way, a mindset of organizing your company, the way you want your company to work. If you want to rely on fast data and be getting insights in real time, you have to use this approach. Obviously, behind this, there are different technologies, and probably technologies will evolve in time. What we see now will change in five months. That's one of the nightmares we have as software engineers. But the idea of having fast data per se means changing the approach to use the data as soon as possible, not just only technology. I hope that that's the answer they were expecting.
Okay, thanks. So another one, somebody asks, what skills does my team need to face this re-architecture?
That's one of the nightmares that I mentioned about the nightmare I have as a software engineer, but when I go to the client, there are other nightmares that they see. Okay, I have my IT team, I have the train, they know everything we use. Now you come with this fast data, and what's going on? I mean, I need to change all my team, I need to fire them all and hire a new one. No, I think, as I mentioned, there are frameworks. Under these frameworks, they are mainly written in Java, Python, which are the two main languages that we find in the market. So if we go to the market and we find people with Java, that person will 80% probability will have the skills enough to build something on streaming, at least. We have to change the mindset about how we work on streaming, but he will have the tools to build this. He will just need the guidance of someone with more knowledge to guide him about the process. But definitely the skills will be already probably in your organization.
Great. Okay, there is another one. Somebody says or asks for, how does my company need to be structured to work on fast data? Is there any special need?
It's just a matter of giving probably the structure that you need for your company is listen to your stakeholders. I mean, if you allow your stakeholders to drive your company in the way, I need my data as fast as possible in this certain type of data, that is how you need to structure your company. But if we talk about how we work, as I mentioned before, is you need to keep in mind that ingesting need to be real time, need to be fast data in the ingestion, need to be fast data in the processing, need to be fast data in the insights, and the stakeholders need to be prepared to use the data in real time. Whatever of these pieces you don't use fast data, you will end up having a partial fast data ecosystem, but it's not going to give you the full power that you probably expect.
Thanks. Thanks a lot.
Thank you.
I guess this was a great summarize also for the session. Well, as far as I can see right now, there is no more question. If I might missed some questions in the chat, be sure we will check afterwards again and come back to you. Well, I would say that brings us to the end of the Q&A session then. So please note that this the recording of this webinar session will be available shortly and will be provided on the GFT website, as you can see right here. And yes, for any further exchange, please feel free to get in touch with GFT and your local contacts. We are happy to help you. And for now, I would say thank you for joining in today and sharing your questions with us. And special thanks to you, Pedro, as well, for this really very valuable presentation. And yes.
Just to add my 2 cents at the end. I mean, just to give you my final thoughts from personal experience. If we, as I mentioned before, we have been working on big data and data projects for a long time. When we start working about big data projects, people tend to think, I'm happy with my traditional system. I don't think I'm gonna need big data, and then they jump into big data a little bit late. When it's just a matter of, it's a fact that it's going to happen, that when you are on big data, you will probably face a situation saying, no, I'm fine with my big data ecosystem. I'm not going to need the fast data, but probably in the next year, you will be in a situation where the market is going to force you to change into that and evolve. Planning this evolution with time will give you the confidence to do it in a proper way and not in a rush at the end. So my recommendation is that if you think that's going to probably be in your pipeline for the next year, try to plan accordingly, and let's see if we can see how it can be done.
Great outlook. So summarize, real-time data is key in industry. So
it is.
Keep on that.
Okay.
Great.
Thanks, guys. Thanks for joining. It's been a pleasure to be with you today. Bye.
Also from my side, stay healthy. Bye.